Hello students, now we'll see question number 6 from the chapter Carbonyl Compounds. Alkene on ozonolysis O3 gives propanone and an aldehyde. This aldehyde on oxidation gives C, and C with bromine and red phosphorus gives D, and D on hydrolysis gives E, and this propanone with HCN and hydrolysis gives E. The compound given is alkene. Alkene has a double bond. Between the carbon atoms there is double bond. This side how many carbon atoms and this side how many carbon atoms, it is not given in the question. This alkene reacts with ozone and forms ozonide. It forms an ozonide. This double bond is replaced by this ozone single bond. So it forms an ozonide. This is the first step, and in the second step the bond breaks and it splits into two compounds. With with this carbon and oxygen it forms one functional group, and this carbon forms another functional group. So here the given is propanone. One functional group is ketone. So this is ketone, and another one is the aldehyde. It splits into two, one ketone functional group and another one aldehyde functional group. And this side propanone has 3 carbon atoms. So this compound, this side of this double bond alkene has 3 carbon atoms, C, CH3 and double bond O. CH3, C, CH3 and double bond O. This is propanone. And this side how many carbon atoms is not given. This we have to find out. Now for that they have given propanone with HCN and on hydrolysis gives E. Propanone CH3, C double bond O, CH3. This is propanone with HCN. It splits into H plus and Cn minus, and this is the nucleophile. It comes and attacks this carbonyl compound. This oxygen gets a negative charge and carbon gets the positive charge. So it is an addition reaction, nucleophilic addition reaction. CH3, C, this oxygen gains hydrogen, OH, it gains a proton H plus, and then CH3, Cn is added to this carbon. Next step is hydrolysis. Hydrolysis of this compound, hydrolysis changes Cn into COOH. So this C, CH3, here it is converted to COOH. This is compound E. And the name of the compound is, here start numbering from the functional group. So it is, this is 1, 2 and this is 3. Second position you have methyl group and a hydroxy group. So it is, the name of the compound is 2-methyl 2-hydroxy propanone. 2-methyl 2-hydroxy propanoic acid. It's an acid, so it is propanoic acid. This is compound E, and this compound E gives D, and D gives from D C we got C. So this C also must have 4 carbon atoms. You see, 4 carbon atoms are present. So D must also have 4 and C must also have 4 carbon atoms. By the way, B must also have 4 carbon atoms. Another one is this compound C on treatment with bromine and phosphorus. This is a naming reaction. The name of the reaction is Help-Olhard-Zelensky reaction. The name of the reaction is Help-Olhard-Zelensky reaction or HVZ reaction. Here this what it says is, this compound, the propanoic acid, whatever acid may be, if it has an alpha carbon atom, it should have an alpha hydrogen. That alpha hydrogen is replaced by bromine and phosphorus. So that the reaction takes place between this bromine and this compound. So if we take this compound CH3, CH3, and this is an acid, and in the alpha carbon it must have an alpha hydrogen. The functional group next to the carbon atom, this next carbon atom is the alpha carbon atom. This carbon atom must have hydrogen, that is alpha hydrogen is present in this compound. If the alpha hydrogen is present in the compound, then bromine reacts. Bromine and red phosphorus, it reacts and forms CH3. See, the hydrogen is replaced by bromine. COOH. This is compound, and this on hydrolysis. This compound on hydrolysis gives E. Hydrolysis takes place. Hydrolysis. So this is compound D and this is compound C. This is compound C and this is compound D. Now we have to find out compound B. Compound C, before oxidation it is an aldehyde. So this compound C, before oxidation, this functional group must be an aldehyde. So we can write as CHO. This is compound B. In the place of COOH, we have written CHO. CHO on oxidation gives COOH. Aldehyde gives an acid. This is compound B. Now we can name this compounds. Now compound B, naming start numbering from the aldehyde. This is 1, 2 and 3. In the second position we have a methyl group. So it is 2-methyl propanal. 2-methyl propanal, because it's an aldehyde, ends with Al. And compound C is in the second position. This is 1, 2 and 3. The second position you got a methyl group. So it is 2-methyl propanoic acid. So this is compound C. Second position methyl group and it's a propanoic acid, 2-methyl propanoic acid. Now the compound D, start numbering from the functional group, and the second position you got a bromine and methyl. So it is 2-bromo. We have to write in alphabetical order. So it is 2-bromo, 2-methyl, second position methyl and propanoic acid. Propanoic acid. 2-bromo, 2-methyl propanoic acid. Now we'll write compound A. A is this B and propanone together, it is A. This one is B. Aldehyde, 2-methyl propanal, and propanone is compound A. The two compounds propanone and 2-methyl propanol add and write, that is the compound A. The name of the compound is, start numbering from the double bond. It is 1 leads to the double bond. So it is 3, 4 and 5. Second position you got methyl group, fourth position methyl group. So it is 2,4 dimethyl, 5 carbon atoms, pent. Second position we have double bond, so it is pent 2-ene. This is compound A, 2,4 dimethyl pent 2-ene. The compound A is 2,4 dimethyl pent 2-ene, and compound B is 2-methylpropanal. 2-methylpropanal, and compound C is 2-methylpropanoic acid, and compound D is 2-bromo-2-methylpropanoic acid. Compound E is 2-methyl-2-hydroxypropanoic acid.